After reviewing volume, let's review mass, weight, and density, starting with density. Here are a couple of pictures that represent density. Density is the amount of matter in a given volume or in a certain amount of space. So this represents high density and this is low density. These have the same amount of volume, but there's more material squeezed into this volume, so it's higher density. And remember, some materials are compressible, such as gases, some are not, such as liquids. But materials that have higher density are going to have more mass and more weight. Remember that mass and weight are related, but they are two different things. Mass is how much matter is in a certain area, okay? Weight is a function of mass times gravity. Gravity is a force, so therefore weight is a force. So mass times gravity is weight. When talking about mass and weight, it's important to use the correct terminology, as most people are in the habit of using technically incorrect terminology. When we're talking about weight, remember that that is a force. In US units, we measure that force in pounds. Most of the time, if someone asked you how much you weigh, you would answer in pounds. But if you were asked how much do you weigh in metric, a lot of people would answer in kilograms, which is technically incorrect. Force in the US units is measured in pounds, and in metric units, it's measured in newtons, named after Sir Isaac Newton. However, kilograms is a measure of mass. In other words, how much material is in a given space. In the US units, we also have a unit for mass, although most of the time it's not used. It's called the slug. So if I weighed 100 kilograms and I was converting from metric to standard, I would convert to slugs to be technically correct. If I was converting my weight to metric, I should convert it to newtons to be technically correct. There is a conversion to go from pounds to kilograms, but we'll discuss that later. As we said a moment ago, weight is mass times gravity. Gravity is a force, and it is measured in distance per time squared. So that's its acceleration. So in standard, it's 32.2 feet per second squared times slugs equals weight. If you were measuring in metric, you would measure 9.81 meters per second squared is the acceleration due to gravity. That's your force times your mass in kilograms would give you your weight in newtons. And let's note our terminology in how it regards to units. If I were applying a force to something by pushing on it, I could measure that force in pounds of force. But if I were measuring the force created by the mass of an object as it relates to gravity, I would measure that in pounds mass. We see the lb sub m. The lb comes from the Latin subscript n means mass. So one slug of mass weighs 32.2 pounds of mass. We look over here at our formula chart and look at the equation for mass and weight. We can see that mass is volume times density, but in this example, mass is equal to volume times mass density. Weight is equal to volume times weight density. So you can use this formula to solve for either one, but you have to denote which units are being used. You can solve for weight density or mass density. And if you remember from this physics formula, this is why weight is a force. Force is mass times acceleration. Acceleration is distance per time squared. So it's our mass times distance per time squared is a force. That's why weight is a force. Now, an applied force would be measured in pounds force, but force of an object would be in pounds mass. So again, if I need to calculate mass density, that's mass divided by volume. If I needed to calculate weight density, that's weight divided by volume.